Good morning. We already started the verification validation chapter, and we have also gone through the model-based testing by taking an example of stack and all. We already gone through, and how test case is to build based on the state diagram and also from the sequence diagram that we have seen it. Right? We will continue from this, and okay. Now let's look into what all the things that we have covered in the last class. If I'm right, okay, we have stopped in the last class. We have gone through the IA question paper 2, and there we have also seen how testing is to be done. That example that we have seen it, right? So, is that okay? Shall we go to the next one, next topic? Arpita, Disha, Ashmita, anybody can respond.
Yes, sir.
Right. Arpita, you continue to respond whenever I ask question. Now, in the
Yes.
last class, we were talking all about the oracle, right? When we talk about the oracle is something like a program, okay, which observe the behavior of a something, right, and try to respond that. It's something like a God, right? It will try to respond for a question. I mean, in this diagram, when you look at that, your program under the test, the inputs are being given, the outputs are being observed, right? And it will tell that one yes or no with an explanation, right? A particular test case is cleared or not. If it is not cleared, right? Why and all these things. This example, this experience, you people have got it through one of the assignment where you have been asked to write the test script for state diagram for the stack, right? Am I right, Arpita? Manoj, am I right?
Yes, sir.
Right. So with this, we will proceed. This is where we are stopped. Right now, we will get into few other inputs, right? Few other concepts, and then finally, we will cover some of the concrete strategies. Right? We talk about the another important thing like a test matrix. Right? List and explain various test metrics. Arpita Nandon and ask Manoj and you people to update in our in-class question bank, right? So when we talk
Yes.
about the test metrics, right, it is a measurement. Metric is nothing but a measurement. How do you measure it? See, if I ask you a question, are you performing, right? There is a metric required. Maybe number of courses you cleared, number of courses you got distinction, right? First time, first attempt clearance of all. These are some of the metric, the measurement that speaks about an individual progress in academics, or maybe the placement we got it, offers that we got, number of offers we got it, whatever that is there, depending on the context. Now, when you look at this, right, quickly we'll go through the. You people can take a screenshot whenever it is required, right? The organization matrix, project matrix, process related matrix, product matrix. We will keep moving into that. When we talk about the organization matrix, right, it is useful in overall project planning and management, right? It is something I can speak about. I'm talking about the quality perspective. I mean, the testing perspective, right? So it shows. Now look at the marking I've done. It shows a quality trend across the organization, right? For example, one okay, beautiful example that's given here. You can read it. The number of defects reported in the field over all the products within 3 months. That could be one of the metric, right? Then right, maybe dropped from zero point 0.2 defects per 1,000 lines of code to 0.004. This is one of the metric, right? Maybe other thing is testing cost per kilo lines of code, right? Delivery schedule slippage. How many times delivery schedule is being skipped because of the not doing testing properly, right? Time to complete system testing, right? That is some metric that we need to get into, right? It speaks about the quality, okay, quality trend across the different projects, maybe across the organizations and all these things, right? Arpita, is that okay when we talk about the test matrix at organization level? Organization, how well it is performing, right? Is it okay?
Yes, sir. Yes, sir.
Right. Okay, please take a screenshot of all these things, because at one place you don't find all these things, right? One place you don't find all these things. Please take a screenshot of all these things. Arpita, taken a screenshot?
Yes, sir, taken.
Right. You can share it to all people. Right. Now look at that. Why do you go for organization level metric? It allows senior management to monitor overall strength of the organization. Okay, previously, I was talking about the quality trend. Okay, the brand of the organization, right? Then also the points to the areas of weakness where exactly we need to focus, and also we need a metric for the senior management, right? Then now coming to the similarly on the same ground, project metric, it is specific to particular project, right? So look at that, useful in monitoring and controlling specific project. And one of the example is actual to planned system efforts in one project metric, right? Yes, right. A test effort could be measured in terms of the tester's man months, right? Here it man refers to both the gender. There should not be any argument like that. Why not? Okay, woman months, right? It is a 1 month of okay the man okay efforts that gets into. Usually the working hours may be 8 hours a day, right? Leaving all other things. Okay, it is being referred. So it is being referred in general as man month. The man refers to the both the gender here, right? Maybe another example given is number of successful tests to the total number of tests in the system test phase, right? That could be another metric used for the project metric, right? Yes. Then, okay, we have a process metric. Okay, when you all people know about that, the goal of the process metric. One moment, I'll enable some people here. Okay, is to assess the goodness of the process, right? When we talk about the goodness of the process, now, maybe any process, okay, that we use. Here is an example, right? Metric that classify the defects according to the phases in which they are found, right? That assist in evaluating the process itself. For example, you have got a different phases in testing. One is called, now look at that, unit testing. We talk about the unit testing, where particular small unit, right, smallest possible unit has been given to individual developer, and that we call as a unit testing. Then integration testing is multiple units developed by different people. We try to put together and make it as a module and all these things. Okay, at that time, how do the different code, different functions, okay, prepared by different developers together, okay, cater for the requirements and all, right? System testing, right? Okay, when all subsystems are being integrated, okay, we will try to validate this, okay, against the requirements, high level requirements, right? Yes, and the defects, defects are found in all these things, right? So you can analyze in each of these phases, right, how many defects being found, corrected, and all these things, right? Process used there, will is it okay, and all these things. Process in the sense when you complete that one, documentation, right? Documentation, conducting the meeting, validating that one, okay, and permitting people to go ahead with the requirement. You design it, you develop it, right? Development is completed, and check in, check out, right? And freeze that when this code is being fully developed and all. Once I freeze that particular code unit and all these things, right? How many such unit after freezing that one, okay, go right without any okay defects found by rigorous testing procedures established. Got it? That could be a metric. It speaks about the health of the process itself. Arpita, am I right? Are you getting convinced with this?
Yes, sir, yeah.
Right. Okay, please look into that. Right. Now I'll get into one and today and then I'll stop it. I will not. Please, I wanted everyone okay to take a screenshot of all these things. Please take it. And it's called okay, product metric is how complex is a product. Right. And how many minimum test cases that I need to check into that one, that I need to look into. Right? We call it as a cyclometric complexity measures. It is proposed by Mark Cabe in 1976. Look at that. And the simple thing, right? You will be constructing for a given graph, sorry, for a given program, all of you listen, for the given program, you'll be constructing a graph. I'll tell you how to construct a graph. And for the given graph, you will find out, okay, apply this formula and find out this number. E minus n plus P, E plus P, where E is number of edges, N is number of node, P is a connected components. For example, right, I'll take you directly, instead of constructing the graph, I'll take you first to the graph itself, right? Consider that you are given such a program, right? And you will be, okay, constructing a graph. How to construct a graph, I will tell you, and you will be making an attempt on this. Now, assume that this is the graph, right? Now, here, the 12 is a number of nodes. 1, 2, 3, 4, 5, 6, 7, 8, okay, a number of edges, I'm sorry. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 is the number of edges, 9 is the number of nodes which are counted, and 1 is connected component. These are all connected, single component. And red color one, whatever you say, when a program exit to end, you, okay, connect it forcibly, right? So this is one connected component. There could be another connected such things, then things are different, right? So 12 minus, 9 plus 1 equal to 4. There are 4 minimum test cases, or you can see that one here. I'll tell you, right? So CC, cyclomatic complexity of a module, is a number of decision in the module plus 1, right? It also speak about is equal to maximum number of linear independent circuit in the graph. Hope you all people understand that. It is set of circuits is a linear independent if no circuit is totally, okay, contained in another circuit, or is a combination of other circuit. Leave it. What is the use of that? It is used as a number of path that should be tested during the testing. Just a minute. I have a call. So I'm back here. So the number, Arpita, I'm audible to you? Arpita.
Yes, sir.
Right. So when you find that number, that it is used as a number of path that should be tested during the testing, right? And how complex is the module, that also you'll come to know. And usually this number, as proposed by Mark K, okay, so that it should be, okay, kept below 10 or below 10. Okay, that is a complexity. Okay, cyclomatic number is a quantitative measure of a module complexity, which reflects number of decision point, which in turn reflect in, okay, the number of path that is to be tested during the testing, right? So how many, okay, for example, if a program is given to you, right, how many, okay, path that is to be tested in this, what is the complexity of this program and all. So for that you need to construct this graph, find out this, okay, complexity is cyclomatic complexity number, which is equal to number of edges. 12 is mg edges minus number of node plus 1, right? 1 is the thing that connected component here. This is the entire thing is connected one component, right? This is that okay? Is that okay?
Yes,
Yes,
sir.
sir.
Right, good. Okay, good morning. Okay, Ashish, good morning. Right?
Morning, sir.
Just have a call, I'll call you. 1 minute.
Yeah.
Come back here, right? So given a graph, this number you find out, and 4 reflect number of, okay, minimum number of test cases that you need to have it, right? So now look at that. What are these 4? Now look at that. Okay, all of you. I think I need to mark. That will be better. Okay. Okay, I'll take this. Now look at that. With the red color, I'll do it. Okay, that gives a number of circuits, number of paths, right? That is to be tested. This is, I have to prepare the one input which will take my program through this and I complete. This is the one. Is it okay? right? Right? Now I'll take the other one, right? It will go through this, my program execution go through that, it will take a turn here and it will complete this. This is number 2. My program will start here, it will take you through all these things, it will go through all these things and this. This is number 3. Okay, my program will start from here, it will take you here. This particular loop it completes, and this is 4. That's what is the number 4, it indicates here. Right? Number of, okay, the path that is to be tested. Right? So it is, okay, 12 number of edges minus number of node plus connected component is 1. Right? Equal to 4. Manoj, Arpita, is that, will it make some sense to you?
Yes, sir.
Right. And please look into that. There will be a question on this in the examination. Right. Given a graph, given a code, you need to write it. Okay, graph and then write it. Right. Then now look at that. How do the question appear? Right. You can take a screenshot. Write a C code segment to sort an array of integers using bubble sort. In fact, this question should not be asked because this code, this particular course is not write a program. Right? Maybe program will be given to you. For a given program, okay, these are the things. Identify various basic blocks. Draw the flow graph. That the graph, whatever you draw, we call it the control flow graph, CFG. Please remember, it is being referred as CFG, control flow graph. Then identify independent circuits. Okay, calculate the cyclomatic complexity number of a CFG. And the cyclomatic complexity number, okay, indicates the complexity of the module. And also I told you that, right, it is the number of paths that should be tested during the testing. Is that clear? Arpita? Arpita?
Yes, sir.
Right. Now the question is, how do we prepare a graph? Okay, for that there is a procedure. Okay, please take the screenshot of this. Please take the screenshot of this. Right? Yes. So please look into that.
Taken, sir, taken.
Yeah, that's good. So please look into that. When for a given okay, program, when you draw the graph here, please look. 1 minute. 1 minute. I'll change the color. Right, blue color. Look at that. See, this particular node. Each node is nothing but a collection of one or more, okay, program statement. Every line of the code, right? It may contain only one line, it may contain several lines, and we call this as basic block, BB, right? Basic block. So you need to, for a given program, you need to identify basic block and keep that basic block and connect that basic block as per the flow of execution. The graph is ready. Is that clear? Is that clear?
Yes, sir.
Right. Construct a basic block, and basic block is nothing but set of programming statements, program lines, right? But what is that basic block? Basic block, it stands for, see here, right? A basic block in a program is a sequence of consecutive statements with a single entry and single exit. Thus, a block has a unique entry and exit point and satisfy the following two conditions. One, what is that? Within that basic block, if one statement is executed, then every statement is executed. That's all. There is no way. And jump is always to the beginning of the basic block. Whenever you make a jump in the program, it will always goes to the beginning of the basic block. Is that clear? Is that clear? This is a property of the basic block, right? If one code is executed, one line is executed, all lines are executed in that basic block. Arpita, Manoj,
Yes, sir. Yes.
right?
Sir, Ashish, sir. It's Ashish.
I'm sorry. Right?
Yes.
See, there are so many classes we take it now, right?
Yes, sir. Absolutely. I understand.
Yeah, my weakness is that I don't remember the name. Forcibly few names are remembered. Arpita, Ashish, Manoj, and Himarashmi. These are all CRs. Okay, I remember. But you all people represent the entire class. Okay, other people should not misunderstand that. No, teacher doesn't remember we people. No, that's my weakness.
Yes, sir.
Right? Okay.
Yeah.
Remember, okay, you as a whole class. That's all. Right? Right.
Yes.
Now, see, now let's look into that. Okay, okay, here is an example. Here is an example. Right? So, I'll try to draw the basic block. Now, let's look into that. I'll take a red color. Right. Look at that. The while loop, okay, it comes here, right? It checks this one and it makes, right, either jump to, okay, the here, it jumps here, or it comes out of that, right? It out. Where is out of that? It is here. Am I right? Am I right?
Yeah, yes.
Yes,
Right?
sir.
When a while loop is executed, doesn't mean that j equal to I should execute, right? So this is one basic block. This is another basic block. In fact, while loop also I can include here, but what happens is while loop, if this is continued, it will jump back. Now, while loop is converted into go to statement. Am I right? Ashish, it will jump. So this is another basic.
Yes, sir.
This is another basic block. Right? Correct. Then after this, you will find, right? So now look at that. Okay, while loop is there here. While, all right, while j less or equal to the n. If this is the case, it will go here. If it is not the case, it will come here. The jump will be here. So this is one basic block. And if this is true, it will execute this jump here, right? This. Otherwise, it will come here. Right. Correct. Right. And this while loop completes here. This is another thing. Right. So you will find that. You'll find that. I'll take the blue color pen. So this is because while loop always, right, the iteration, the jump is always to the beginning of the block. This is the one, right? Even if statement, if the if statement is executed, doesn't mean that the next statement should be executed. No, if it is true, then only execute. So this is isolated out, right? And swap, this is a case separate one, right? If a statement is executed, if it is not executed, it doesn't mean that it should execute here. If this is executed, doesn't mean that it should execute the swap. If a condition fails, the swap doesn't execute at all. Got it? Are you getting this? Alright? Then
Yes.
this is the another block you will find here. Right. So I equal to I plus 1 is another block. So you have to number it as a basic block 1b1. Okay, you have to have a b2. You have a b3, and you need to check it out. Sometimes, okay, you may do the mistakes here. b4, you have a b5, right? Sometimes, okay, if a basic block is wrongly identified, then you may end up with a problem. You will be correcting that. Okay, now look at b8. Now, how do you draw this? Right? How do you draw this? I have got the basic block b1. Right, you draw this. It contains only one statement, right? And if this is executed, while loop also will get executed. But what happens is because of the looping, jump is always to the beginning of the basic block. So B1 and B2 isolated. Are you getting this? Otherwise, B1 and B2 we have merged it. And we draw the statement like this. Are you clear? B1, B2 are merged it, but what happens is when the while loop, okay, it goes to the end of that, and again it comes back to the beginning. So always there is some looping is there, right? Then I have a B3, right? I have a B3, right? Then I get into B4. Then I get into B4. Right? Now look at that. From B3 you jump to B4. Right? Then Okay, B5 is different. So from B4 you go to B5 or you directly jump it. B4 you go to B5. Then you have a B6. With all connected things we do. B6, right? Okay, you proceed like this, right? You proceed and probably okay you will get these things. You probably will get these things. Okay, but anyhow, see there is a same graph or something. B6, right? Then 1. Yeah. Then you have B7. Then you have okay B8 and we'll see it. B7 to B8, B7 to B8, no. Where exactly? Okay, B7, okay, B7, okay, you get to B4. Am I right? Look at the for loop. You get to B4, right? Then if statement is there, this is executed, right? When B5 to B6 it is there, if statement is there, and execute, right? If this fails, right? If it fails, right, it comes to okay B7 directly. Do you agree? Arpita, Manoj, sorry, Ashish? Yes,
Yes, sir.
right. Based on that, okay, jump and all you need to drop, right? Then B7, if it is executed, B7 is a loop, right? That is from the B4, what happens is, okay, B4, if this fails, you directly come to B8, am I right? B8, J less than N. If it is fails, then directly you come to I equal I plus 1, am I right? Yes or no?
Yeah, yeah, yes.
Right. Okay. B4 to B8 you will get it. Then B8, okay, you go back to B4, am I right? You go back. There is a loop. There is a loop.
Yeah. Yes.
Right? Yes. Are you getting this? Okay, then B1, right? What happens is, right, red color because it's a single program. Now what we'll do is ink, now I'll change the ink color, right? I'll put the dot here. This red color, whatever that is there, right? I'll put it here just to complete this. This is one. I mean, this is not a loop here, right? It terminates, right? So you need to identify basic blocks and all. Basic block has a property. If one statement is executed, all are executed, and jump is always to the beginning of the basic block. Thereby you identify. Now consider that for given this graph, right? So when you cyclomatic complexity number you calculate equal to number of edges minus right node plus one connected components, right? We talk about like this edges. You see here 1, 2, if at all it is being done correctly, 3, 4, 5, 6, 7, 8, 9, 10, 11. Hope we are done correctly. 11 minus number of node is 8, right? Okay, plus 1, right? This is equal to how much? How much? 4. Is it clear? And this will indicate the number of minimum number of paths to be executed, right? Yes. Let's check into that one. How many paths that we have, right? So I'll change the color. Blue color is not that visible. I'll take a maroon color. Now look into that. Here, you come here, come here, you come here. This is one path. Do you agree? Then you come here, then you take this path. This is the second path. Right, right. Then you come here, you take the third path. Right? The another thing is, okay, you come here, you come here, you come here. You take this path. Okay, this is the fourth path. Right? So is it equal to 4? The number is, this is how we found the complexity of number, okay, number of decision point, because whenever there is a diversion in the code, there is a decision, either if statement or while loop. So complexity of a module is, okay, should be kept below 10. It means that number of decision points should be less than 10, if then else, or while loop, or whatever it is. So this is how we, given a program, we do it. Is it clear? Is it clear?
Yes, sir.
Right. And I've given another example here, right? You can look into, consider that this is the graph, right? How do you compute? Then I'll give another thing which you can try. This is an exercise for you, right? Please take a screenshot. This is an exercise. With this, okay, we will stop now because I have got another session to begin. But another 5 minutes, okay, I will recollect whatever we have done. So this is an exercise. Ashish, you take a screenshot and put it in our in-class
Yes.
question bank.
Yeah.
Find the cyclomatic complexity number for the given program. Please note down, all of you. And the program is given to you and you need to draw the graph and compute cyclomatic complexity number. Or you may get a question for the given program, find out the number of path that is to be tested using cyclomatic complexity number. Or for the given program, find out the minimum number of test cases to be designed to test the path. Ashish, okay, is that okay? Have you noted
Yeah.
this? Have you noticed
Yes.
this?
Yes.
Right. Such a program will be given and you will be asked to, right? Do this, and here is a solution also. You can try, right? Basic block 1 includes line number 2, 3, 4, 5. Entry point is this, exit point is this. Why? Check it. Note down the screenshot. And you can refer the internet and try to get many examples. Right? Here is a solution, right? As a case study, you can take it and work out. So in this case, there are 9 basic blocks. Right here is a 1. Yeah. Any question now? Right? And a question something like this sometimes may appear like this also. Ashish, you can take a screenshot of this and put it in our in-class question bank. Write a C code segment to do something. Identify various basic block. Draw the control flow graph. Identify independent circuits. Calculate cyclomatic complexity number of a CFG drawn. Ashish, taken a screenshot.
Yes, sir. Yes, madam.
Put it immediately, today only, so that other people can
Yeah.
refer.
Yes.
Right.
Yes.
Now, I'd like to, what I can say, summarize the things, the algorithms. Okay, you can note down this algorithm also. Break the module into basic blocks. These basic blocks, okay, these blocks form the nodes of a graph. If the control from block I can branch to block J, then draw an arc from node I to J. Simple. Draw an arc from exit node to the start node, which I told with the red color, which makes it strongly connected graph. Exit node to start node. But with the dotted lines, you will be putting like this. I'll show here. Right here you can look into. Okay, strongly connected graph. This is the procedure that we use. But what is the basic block? When we talk about the basic block, it is a sequence of consecutive statements with a single entry, single exit. If one is executed, everything is executed. And branch jump is always to the beginning of the basic block. If you look at the jump initially everywhere throughout program, wherever jump is there, mark it is a beginning and all. And look at that from the beginning, what all executed, okay, executed in totality, either executed or not executed. Right? So with this property, we'll be identifying basic block. Likely that sometimes people do mistakes also. Right? Then this is the formula we use. Right? Then another important thing I forgot to tell you, look at that. The cyclomatic complexity number, it is being referred as cyclomatic complexity number. Let me tell you about that. Product matrix, yeah. Cyclomatic complexity measure proposed by McCabe in 1976 formalized this. And what is the use of this is that this number is the quantitative measure of a module complexity. And always complexity is to be kept below 10 according to his recommendation. Right? And is used as a number of paths that is to be tested during the testing. Right? And always it speaks about, right, look at that, it is equal to maximum number of linearly independent circuit. Right? And it refers to the number of decisions in the module plus 1. Number of decisions in the module, because whenever there is a branch, please look into that. Whenever there is a branch here, now look at that. Okay, here is a 1, here is another 1. Whenever there is a branch, okay, there is a decision. Say for example, in B4 there are 2 paths here. Right? B4. Now look at B4. B4 has a while loop. There is something. If a while condition is true, it gets into 1. While condition is false, it goes to somewhere. It's called decision. How many such decision points are there? Right? That will decide the number of paths. Right? Are you clear about that? Right? So it speaks about, look at that. I told you, it speaks about number of decisions in the module plus 1. Right? Now you can very easily understand number of decisions, how many decisions are there. Okay, here is one while, here is another while, here is another if. Right? How many such things should be there in a module? Okay, the McCabe, okay, he says that one, okay, it should be kept below like 10. Right? In the year 1976. Right? Where none of you were born. Am I right, Ashish?
Yes, sir.
Right. Okay. I mean, but there are, okay, this is just a study. Right? There might have been progress, changes, and all these things. Okay, module complexity. Today, the people manage maybe a different value. Right? It is an indicator. Got it? If it becomes more than 10, it becomes difficult for any individual to comprehend that the logic given in that particular program in totality. And please remember, right, for a placement preparation, many times a code will be given to you and people will ask you how does it works, right? Whether it's online, offline, whatever it is. So you should be ready with this kind of thinking, right? Ashish, am I right?
Yeah, yes, yes, absolutely.
Right. So just check, validate that whatever the graph I've drawn is correct or not. Okay, if at all there is a possibility, sometimes we miss it, some of the things. So you try to be careful when you are drawing this, right? So please remember, underline that. Find out, red color one, it can be converted into question. Find the number of paths that should be tested during testing for the given program. Ashish, you can restate your question noted earlier. It is getting closed in next 2-3 minutes. Okay, I'll stop. Identify number of paths that should be tested during testing. So you should not simply directly read the code and write it directly. Rather than that, you should use a strategy. What is the strategy? Draw control flow graph and then apply the formula, right? Find out this and say that one, these are the 4 paths. Are you getting this? Right? Okay, is always +1 because connected component, we add it from exit to entry. Okay, like this. So that will add it to 1. Okay, yes. Is that clear? Otherwise, it is 3. The decision points are 3. Okay, where are they? One is here, other one is here, right? One take you here. 2, 3, and 4 here. Because there is a one which takes you through this, no, that's why. Okay, this is an added because here. So it is always this. Please look into that. Right? Is that clear?
Yes, sir.
Yes, sir.
So please work out. So this is called as a cyclomatic complexity of a module. Okay, and I think we are done. And all of you remember, tomorrow is a holiday, am I right?
Okay.
Tomorrow is holiday. I know I'll come back to you. And I wanted to take a class tomorrow. Okay, sharp 9 o'clock. I'll be taking 9 to 10, 10 to 10:30. 2 sessions. Okay, preserve it for that.
Okay, sir.
Okay, all of you remember, Ashish, you can put it that tomorrow 9 to 11 software engineering class is there. Everyone must attend. And important testing strategy I'll tell from career point of view, from placement point of view, from exam point of view, all are important. Nobody can afford to miss it. Okay,
Yes, sir.
9
So in the
to 11. 9 to 11.
yes, in the morning, right?
Morning. Morning.
Yeah.
Right? Okay. With this, I will close my session. Is that okay?
Yes, sir. Sure.
Right. Okay. I'll be ending this meeting. Tomorrow, 9 o'clock, we'll meet.
Yes, sir. Thank you, sir.